1, 2, 3.
Hey.
Hi! We were all counting down.
That's
That's what happens when our countdowners are not. Hi, welcome back. So we're graphing exponential functions. This time we're going to add in that extra step of the transformation. So we're just going to remind ourselves, we'll do it here on this first one, the general form of transformations. This should already be on your 3x5 index cards. If it's not and you want to take a picture of the rainbow explosion I'm about to write, then you are more than welcome to take a picture of that. You put it on a 3x5 index card and take those into tests and quizzes so that you have access to it. Here is your general form for transformations. All right, you remember that thing?
Yes.
Yes.
Yeah. What did this letter out here control?
The compress, the stretch.
Compress and stretch. Do you remember if it was vertical or horizontal?
Vertical.
Good. So this controls vertical compress and vertical stretch. What else does it control?
The
Reflection. Correct. Across which axis? The X or the Y?
egg.
The X. Very good. The reflection happens when we have a negative sitting in there. The vertical compress happens when I have something smaller than 1 sitting there. And the vertical stretch happens when I have something bigger than 1 sitting there. Very good. What did this control?
The stretch.
That controlled.
Also a stretch or a compress, but this time in the horizontal. Good. What else did it control?
What did that control if it's gonna stay negative or positive?
Yeah, it also controls what happens here. If it's negative, we have a reflect in Y, and we have the control of motion of this thing. Normally, a negative shifts it to the right and a positive shifts it to the left. But when I have this thing happen with a Y reflects, we're going to change this to be the opposite. So negatives shift it to the left and positives shift it to the right. Okay? Horizontal compressions happen when that is bigger than 1, and horizontal stretches happen when it's less than 1, which feels opposite of the A position. All right, this one out here controls what?
The
What direction?
up and down.
Up or down, yeah. So if it's plus, it's going up. If it's negative, it's going down. Right? All seems really familiar, yes? Good. Feeling comfortable again. Good, good, good. All right. I'll give you guys a few more seconds to jot that down. Feel free to add those colors if you like. In case you want a few more color options. All right, let's look at this transformation. What's happening there?
It is being negative.
Yeah, -9. Which direction does that move?
Right.
To the right. And this?
Up 7.
Good. Let's look at the middle one. We're going to keep our cheat sheet handy. I've got that left or right motion again. I've got that up or down motion again. But this time I also have
Vertical.
if we've got numbers other than 1, but since I don't see numbers there, I just have a negative, there's no vertical stretch or compress. But there is?
Reflect
What axis?
the X.
Good. So this I've got a reflect x-axis. Notice how now I'm writing them as bullet points. I'll color code my bullet points so you know what's controlling what. The next thing I have is that left or right. Which direction?
To the right.
To the right. Very good.
Is the vaccine negative or anything?
Left. Yeah, no, and I agree with you completely. And so that's why on the transformations you've got to kind of, it's backwards for reflections unless, or for transformations, unless this position is negative. In which case it works exactly the way you want it to. Okay. And then the last one is which kind of motion?
Up to
Very good. Okay, we're taking away the cheat sheet now. Okay, looking at this, I have that, so that's going to happen. I have this, so that's going to happen. This time, though, the negative is inside the parentheses next to the x. A reflect across the y. Very good. But we have a y reflects. Whenever we have this y reflects, that thing moves the way Sierra wants it to. And she wants it to the right when it's positive.
Oh, because of the negative.
Yes, because of that negative. Okay? So be real careful with this. Okay? Look at the difference. This one does not have a y reflect. This one does. All right, let's turn this one into a complete sentence. The mm-hmm.
Negative X. Has been reflected.
Mm-hmm.
2 units right.
We're still on this one.
Across the y-axis.
Very good. And
2 units right.
shifted. Shifted 2 units, right?
4 units.
Good job. Perfect. Yes, ma'am. Yes, of course. Yes? Okay. That's an example of a beautiful, beautiful sentence. Notice it has all of the parts showing. Oops, I put that in the wrong column. Okay. It's got all of the parts that we talked about. Okay? All right. Let's talk the transformations of these, and then we're going to graph them. Okay? We'll only do one of the graphing. I think I want to graph either one of these two. Okay? But before I graph, I need you to fix the typo. This g of x shouldn't be there. He should be over here. I don't know. He must have gotten into a fight with his equation or something. He just decided to be on the other side of the paper. I don't know. All right. We're going to look at this one. This is my original graph. Note, I'm not saying parent function. Exponential functions don't have a parent the way the other functions do because that base can change. Okay? So while you get that feel of kind of a parent function when you're looking at the base by itself without all this other stuff happening to it. It's not technically a parent function, okay? So this is my original function, this is my transformation. So let's look at the transformations we have. I have that, which is
Right 5.
beautiful. And this,
Up 2.
good. So we have our little legend to the right 5, up 2. Good. Let's look at the next one. I have this
Reflect
across.
the X.
Good. So I have a reflect X. And then this,
Right 2.
I have a right 2. Good. And then this last one.
Reflect y-axis.
Reflect Y.
Oh,
Good. And then,
Down 2.
down 2.
good. I think I want to do this one, the one in the middle. Okay? I want to do the one in the middle, and I would like to add something to the graph. Can I please have a number between 1 and 5?
2.
I heard 2.
2.
3.
2.
I heard 2.
2.
I'm sorry. I heard 2. All right. So please add in a reflection down 2 units. Okay? That says down, not clown. Like what? We're going to clown 2. No, we're going to go down 2. All right. So now I know the transformations we're going to apply. I'm going to start figuring out how to graph my first function, h of x. And I'm going to graph it in blue. Okay? Before I graph it, I need first the horizontal asymptote.
Right equals 2.
Perfect. And then I need to know, is this thing a growth or a decay?
Growth.
Good, because this
Bigger
is
than 1.
perfect. All right, now when I go to my graph, I know that this thing is going to look something like that, and that I have an asymptote at y equals 2. That means toward the left, and there's no reflections, right? No reflections on the growth. This means that toward the left side of my picture, I'm going to start getting closer and closer to 2. Yeah, I'm going to start getting fractions and decimals. And on the right side of the graph over here, I'm going to start having bigger and bigger positive numbers. Okay? And that's going to help me when I make my choices for exponents. The first exponent that I want to choose is going to be the exponent of 0. So I want my exponent to be 0. What value of x makes that happen? 1. Because 1 minus 1 is 0. Okay? This means that at h of 0, of h of 1, my exponent is 0. Okay? This prevents me having to do what we did on like day 2, where you had to write out everything and substitute into the exponent and then add the things and then, you know what I mean? Just makes it super simple. You can immediately write the exponent. Anything to an exponent of 0 is 1.
3.
And 1 plus 2 is 3. And so my first point that I'm going to graph is 1 comma 3. Now I've already decided that because this is a growth, things to the left of it, of this spot, are going to start becoming fractions, and things to the right of it should stay whole numbers. So if I think of my exponents as like a number line, so here's my number line of exponents. And I have my 0 exponent, this one right here, okay? I have my 0 exponent sitting there. I want as few hops to the left as possible, because every hop I have to do is another fraction I have to calculate. I don't want to calculate fractions. So let's just go 1 to the left. So I want an exponent -1. And so I get a good clear picture. Let's do 2 hops to the right. So I want an exponent of +1 and an exponent of +2. Okay? With me so far on the hops and the exponents that we're looking at? Okay. So what we want here is I want x to the -1. I'm sorry, 3 to the -1. 3 to the 1 and 3 to the 2. Okay? Here's the rest of my function. These are starting to get really kind of crammed together, so I'm just going to put little there so that you can see them easier. Let's go figure out what values of x make these happen. Okay. Looking at the graph, I figured out that when x is 1, my exponent is a 0. Okay? 1 hop to the left gives me an x of 0. 1 hop to the right gives me an x of 2. And another hop to the right gives me an x of 3. Those are the x values that make those exponents that I wanted happen. Are we okay with that? Is that okay? Okay. Yeah, I'm just kind of looking in all different parts of my room to make sure that I get at least some sort of, yeah. All right. Okay. So now I'm going to evaluate these. When we have a negative exponent, take your base, flip it over, make the reciprocal of it, reapply your exponent. Okay? The reciprocal of 3 is 1/3. My new power that I'm applying is a 1. Is a +1. I don't need to write a +1 exponent. So I'm just going to write without the exponent. So this is 2 1/3. And so my point is 0, 2.3, repeating. I transferred that into a decimal for you because I know that some of you find the decimals easier to plot than the fractions. Okay. Anything to the 1 power is 3. I'm just continuing on. And then there we go. And now I have 4 points to plot. Okay, cool? All right, let's do it. So, 3. Now notice that I'm drawing these dots like way bigger than I normally do when I graph things for you. And it's because we need to see these dots very clearly when we do the transformations. And there it is, looking not too terribly unlike what I had thought in my head a growth should look like, which was the yellow thing that I drew. Okay. And I'm going to label this h of x. And I got a huge thumbs up from someone toward the middle telling me that I actually did it right this time. Go me! Now we're going to graph the transformed function. Okay? That's this one here, which I've already identified what I'm going to do everything about the blue graph, including the asymptote, in order to generate the new graph. Okay? I'm going to reflect it across the x-axis. I'm going to slide it over to the right, and then I'm going to shove it down 2. Okay? I'm going to do that to the to the horizontal asymptote first. Okay? Here's my horizontal asymptote right here. It is 2 units away from my x-axis. So I'm going to go 2 units away. This is where my new horizontal asymptote is going to end up. Note I'm not drawing it across the graph yet. I'm just indicating where it is right now. The next thing it asks me to do is shove it over to the right. But it's an entire line, so shoving it to the left or right doesn't do nothing. So I'm just going to skip that one. Okay. Then it says, shove it down 2. 1, 2. My horizontal asymptote
-4.
is now here at -4.
The y equals -4.
Okay, there's my new asymptote. So far, so good? We're okay with this? Okay. I'm going to do that same process to every point on my graph, okay? And I'm going to keep track of all of the little motions. I'm going to use a pencil, and I'm just going to, like, put little X's where things happen, okay? All right, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 away from the x-axis.
Whoa.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 away from the x-axis. I have reflected it. Then from that location, I'm going to shove it 1, 2 to the right. It's now in this location. From there, I'm going to shove it down 2 spots. It is now in that location. Okay? First thing I did was grab it and I flipped it over the x-axis. And then I'm going to zoom in really carefully. You see my little arrows? Shove it once, shove it twice to the right. Then from there, once, twice down. That's my new point. Okay?
Yes.
Why 2 down? I had changed the equation and added a -2 at the very end. Thank you. All right, that's this one. Repeat that process for the remaining 3 points and then connect them smoothly with a beautiful curve. Okay? So that's what I'm going to do. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We are now here. Shove it over to 1, 2. We're now here. Down to 1, 2. Oh, that feels.
No, miss, it's because you put it on the third one,
Oh, yeah. Yeah. So it's 5, I said, right? So 1, 2, 3, 4, 5. Okay, there it is. And then we shove it over 2. And then we shove it down 2. And it's right here. Thank you. I was starting to realize, I was like, wait. What? 1, 2, 3. 1, 2, 3. To the right, 2. Down, 2. All right, this one is super close to the asymptote, so I'm going to move the asymptote and then step away from the asymptote just a little bit on the side where the rest of my points live, okay? So it is 2 spaces, so 1, 2, to the right 2, down 2. I'm on my asymptote, and then I'm going to shove it like really close to the asymptote, so on this side, right there, okay? That's how you graph those ones that are really close to the asymptote. Is just grab the asymptote, move the point as if it were on the asymptote, and then step away from it just a little bit. Okay? Okay. And then just as smoothly and as beautifully as we can, I'm going to connect the grid. As always, my habit is when I'm getting close to an asymptote, I only draw one of the arrowheads. I don't draw them both. And then label my graph. Peachy keen?
Where does that come out? A nice where I've heard it before.
I don't know.
It comes out in
My mother-in-law says it, and she's much older than I am. So it probably comes from her high school days, which was a long time ago. But I'm not going to age her and say that would be me. All right. Any questions? That's all I had today, guys. Thank you so much.
Bye.